All right. Let's go ahead and go through a couple if you have questions. So on your work from last night, again, these are all answers. Are there any up here that you'd like me to go over and do? Go for it. Number six. All right. On number six. So in this section, we're solving by rounding to the nearest tenth. So for number six, you had an angle given to you of 44. You need to first label that figure so that you can say what parts you have, because your ratio that you're going to use depends on what parts you have. So for this one, you have what two pieces are labeled. So you have 19 and X. I mean, I can redraw it if you want me to over here. So, and this is 19, this is X, this is 44. All right. Yeah. Well, hypotenuse is always across the right angle. Do you have that hypotenuse? No. Opposite. So the 19 is our opposite. And X is going to be our adjacent, because again, it's based on this angle. We have the opposite leg and the adjacent leg. Adjacent's next to, opposite's across from. So now we know what parts. You have to look at SOHCAHTOA. All right. If you don't know SOHCAHTOA, then write it out each time. Some old hippie caught another hippie tripping on acid. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Opposite and adjacent is tangent. So tangent of, again, the angle measure, 44 equals what over what? Opposite over adjacent, 19 over X. Now, this one was a little bit tricky because X was on the bottom, so it did make an extra step. The first step's always the same. We have to get rid of our denominator. So on here, X is on the bottom, so we're multiplying by X. Times X, times X. So we end up with X times tangent of 44 equals 19. Yeah, those cancel off. But now, this is where we had the extra step. We multiplied our denominator, but our variable is not by itself yet. We need the variable to get by itself. So on here, we have to get rid of that entire tangent of 44. Well, tangent of 44, that's an actual number. It's being held onto X by what operation? Multiplication. That's what we need to undo. We need to undo the operation of multiplication. So the opposite of multiplication is division. We're dividing by tangent of 44 to get it over to the other side. Now we should get an answer. So 19 divided by tangent of 44. Now you're plugging this into the calculator. You have to be careful when you plug it into the calculator. You make sure that you know how to plug it in. So every calculator is slightly different. Some of them you have to hit the tangent button first and then type the number. Others you want to type the 44 first and then hit tangent. Majority of the calculators that you're using, if you're using, say, the little black TI 30XA, or if you're using an iPhone to do these, then you're going to do the number and then tangent. So like on this one, you have to hit 19 divided by 44, hit the tangent button, it'll give you a decimal, and then hit equal. If you don't hit equal, it's not actually doing the whole problem. So when you do that, you should get roughly, what number was this again? 6. So the answer they got was 19.7. Now, if you didn't get that answer, again, you might type something in wrong. So double check your work. Also, when you're looking at this problem, you should be able to identify a range of values that should make sense. So for example, here we have this side with 19. should this side be smaller than or greater than that 19? Now, I already gave you the answer, so we know it's greater. But just by looking at this, we should know it's greater. The reason why, if this is 44, that'd be 46, right? Again, geometry angles are always complements. So I know that the one across from that should be bigger. Essentially, if I have a right triangle and they're complements, we know 45, 45, 90 has two legs that are always going to be congruent, right? If an angle is greater than 45, then the side across from it will be the bigger of the two legs. If I have an angle less than 45, then I'll be the smaller of the two legs. So here, that should have been smaller. I got a number that was bigger, not by much, because the angle is very close to that 45. So that makes sense to be 19.7. Anybody having trouble being 19.7 in their calculator? Again, each calculator is slightly different, so you want to make sure that you can get it. 7? Yeah, I can do 7 next. 7 and 2. All right, on number 7. So on 7, kind of the same idea as that one over there. We have two sides. We're using 32 this time. So first off, the x is across from the right angle. That's our hypotenuse. The 18, that's next to the 32. So that's our adjacent. So we have adjacent and we have hypotenuse. So for number 7, we're going to set this up. We have which one of our ratios is adjacent and hypotenuse? Adjacent and hypotenuse. That's opposite hypotenuse. Adjacent hypotenuse. And C. So cosine. So we're doing cosine of the angle measure to adjacent over hypotenuse. This is another one with x on the bottom. So the steps are pretty much identical to what we just did on the last one. Multiplying by x. Once we multiply by x, that side's canceling off. I'm going to rewrite this. I have x times cosine of 32 equals 18. Get x by itself, so divide off cosine of 32. Cancel off. And again, whatever I get here will be my answer. So plug that into the calculator. 18 divided by cosine of 32. Practice typing it in. Make sure you get the correct answer. The answer on this one was 21.2. And just like on the last one, if I look at my values here, x, the one we're solving for, that's my hypotenuse. Since I'm solving for the hypotenuse, that means I'm solving for the biggest side of this triangle. So I should definitely get a value that's greater than 18. And did you get a number greater than 18? So there's a good chance I'm right. So you want to round to whatever they tell you to round to. Now, if you choose to round something early, so say like on here, I have 18. I like just putting that whole thing into the calculator. 18 divided by cosine of 32. Some people will do cosine of 32 first and get decimal. If you decide to do that route, you always want to make sure you use extra decimals when you do the part of dividing. Because if I just say got my answer for this and had 2 decimals, I'm not going to get the correct answer. I need more decimals. So if I plug this into the calculator, go out like to 4 or 5 decimals, write that down, and then divide it, and you get the correct answer. But you always want to keep extra decimals until the end. So if you do decide to round something off before you get to the end of the problem, keep extra decimals. If it says round to the 10th, keep like 3 extra decimals on there, 4 extra decimals. That way you don't have as much rounding error. Let's see what that does. Nothing. All right. Let me see. I don't see type it in. Okay. So what you just did is not the same as what's up there. Essentially, what you just did was cosine of 18 over 32. I had a fraction with a cosine b. Clear? 18 divided by. Now, in this calculator, you're going to type the 32. Get cosine. So now that's the cosine of 32. That's currently on what you're dividing by. It equals. That's your answer. If you need to, you can round that off, but just make sure you keep extra decimal. Anybody else? I thought I heard another number. I forgot what it was. 2. All right. 2. So on this one, we're just setting up a fraction. It just asks for a ratio. So it says sine of x. Well, here's x. For sine, we need opposite and hypotenuse. So this side's opposite. This is hypotenuse. So opposite is 21. Hypotenuse is 35. They're both divisible by 7, which leaves me with 3 and 5. That's my answer. Check, see it. Probably done that. So sine of x. So they told me which angle I'm using. Sine is opposite over hypotenuse. This side is opposite, right? It's a cross side. This side is my hypotenuse. I'm just doing the 21 over 35 fraction. And then I reduce that to 3 over 5. They didn't ask us to actually solve for anything. They just wanted us to write our ratio. Yeah, all right, so this one's doing an angle. So on this one, let's see, we have this angle is the one we're missing. I'm going to call that x. All right. As far as the sides, this is our hypotenuse. This is our opposite. So I have opposite and I have hypotenuse. Well, opposite hypotenuse is which one of the 3? Sine. So I'm going to do this work up here. So for number 11, we are definitely using sine. So sine of the angle, which I call x, is equal to opposite over hypotenuse. So opposite was 22, hypotenuse was 23. We have ourselves our equation. Now we're solving for x. There's no addition or multiplication or anything else going on over here. The only thing that we have is sine of x. Sine is our operation. We need to get rid of sine. The opposite of these ratios is the inverse. So that's where you use the sine to -1, cosine to -1 on your calculator. If you're solving for an angle, you're going to have to use the inverse operation. So here we're doing the inverse sine of 22 over 23. Now, I don't always write it out, but essentially what we did here, just so you can see it, I took the inverse sine of both sides. It canceled out over here. Inverse sine to this side, and that's what got us to this step. Again, it's just like any other operation. We're using it, so we're doing the opposite, so that we're canceling something out. Now, plug that into the calculator, and what do you get? Well, you should get an answer that's an angle measure. So if we look at number 11, on number 11, I don't have any angle measures there, but just based on that diagram, this is my longer side. So my answer here should probably be greater than 45. Now, what is my actual answer? Once I type this in, should give me somewhere around 73 degrees. Yeah, you did have to round it off. So it's 73.1, 73.04, and round to the nearest degree. So rounding to a whole number. That's it. Okay, let's go ahead and move on. I did not pass out the worksheet yet, right? Okay. Grab those. Again, they're supposed to be what I try to set them as is 5 minutes into the class. So you should, yeah, we went over this, so technically like, now I can't get submitted because I won't take out my points if it's right away. Those answers are actually posted. Yes. Oh, okay. All right. Okay. All right. That you want to get. Next one. That's what we're doing today. It's essentially the same stuff that we've been doing. This is the only thing that's new. Even some people have, but other than that, it's the same. Don't worry about it. Yes, I would be posting it. So you can skip. You don't have to do that one, but you have to do that one or that. But I want you to try the rest of it. All right, was there anybody else I missed here? Did I give you one? Did you get one minute? Was there anyone else I missed? All right. So. Back down here. And let me change this to save, clear. All right. So on this page, we got we are now looking at word problems. Now, when we have word problems, we have word problems of any of the stuff that we've done. All right, this is mostly focusing on sine, cosine, and tangent though. Still, so again, we could have word problems with Pythagorean theorem, we could have it for special right triangles, and we can also have it for our trig ratios. On here though, there are two key words that we need to know the difference between. So we have angle of elevation and angle of depression. Essentially, angle of elevation, just like this diagram is showing, is going from a horizontal line and up. So this angle, and it might be hard to see on your papers, but there is an arrow there. So it's going from a horizontal line and going up. That's the angle of elevation. Angle of depression is going from a horizontal and going down. So same thing right here. Again, it's really hard to see. I know I made my copy small, but it is a arrow going down. So angle of elevation going up, angle of depression going down from a horizontal. Now, a lot of times in problems, you'll have both an angle of elevation and depression in the same problem. So on this example, all right, I'm going to draw for a second. Actually, let me just draw a new one off to the side. I'm going to use the same example, but I don't want to draw that diagram. So I'm going to draw the person again. I'm going to draw my large tree over here that looks horrible. Oversized Christmas tree. All right. I'm going to draw one little extra piece on top. I'm going to make a little bird. All right. So, I'm artist. All right. So, on here, we have going from the person up to the bird, there is an angle of elevation. Going from the bird down, there's an angle of depression. Now, a lot of times they may give us a triangle in one of these two parts, but it might not always be where the angle is. So it's important to understand one key thing about these two angles in the same problem. These two angles will always be what to each other? Congruent. Why? You're right. That's where I was looking for. They are congruent. You know why? Okay. They are, but why? So what properties from earlier on allow us to say this? Say it again. Alternate interior angles. These two are considered alternate interior angles because we have the horizontal lines. Since the angle of elevation and angle of depression are from horizontal lines are always parallel. So since we have two parallel lines we can use, the ones on the opposite side, this line of sight is acting as our transversal. So we have opposite side of the transversal and the inside the two parallel lines, making them alternate interior angles and making them congruent. So if they give us an angle of elevation, we also know the angle of depression. We know the angle of depression, we know the angle of elevation. It should be the same. Questions there? All right. Other than that, this is all the same as what we've already been doing. It's just word problems. So let me say that, and then can I move this up? Can you do it? Okay, so the examples. So the first example says a hilltop, and they give us a diagram. Most of these will give us a diagram. Now there will be a few here and there that don't have a diagram already drawn. So what do you want to do if they don't have a diagram? Wrong one. Yeah, because if you don't draw one, it's hard to identify opposite, adjacent, hypotenuse. So always draw a diagram if they don't give you. All these examples give us a diagram. They show us that point A over here, from there to the top of the hill, has an angle of elevation of 49 degrees. They also said that it's 400 feet from the bottom of the hill. They want to know how high the hill is. So there's our X. They gave us a right angle. We need to label it, just like we've been doing with all of our other SOHCAHTOA stuff. So on here, we have 49. That X is on what side compared to the 49? Opposite. The 400 is where? Adjacent. Again, we labeled those based off of that angle. So we have 49 degrees. Now we have opposite and adjacent. Again, use your trig ratios. Now, write it out one more time. Some old 50. Caught another 50. Tripping on acid. Cosine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Same thing. So we have opposite and adjacent, which makes this a tangent problem. So plug them in. Tangent of, what's our angle? 49 equals X over 400. Now, before we do anything with this problem, just to get an idea of what our final answer should be, look at the numbers we have here. If this is 49, well, first off, 49 is more than 45, right? So this side that's over there should be bigger than the other leg. So if this is 400, my answer should be greater than 400. Because in a right triangle, if they were the same, they'd be equal, right? So if they're both 45, they'd be equal. If they're not the same, so one of them would have to be more than 45, one of them would have to be less than 45 because they are complements. They still have to add up to 90. no matter what. So on here, this number is greater than 45. So that means that that's the bigger of the two angles, which makes that side the bigger side. Again, it's just a way of checking if my answer makes sense. So if you look at those angles, it should help tell you, all right, will my final answer make sense? I know it should be more than 400. How much more? I don't know. Sometimes on multiple choice tests, that's a good strategy to look at because sometimes the only answer that might be there might be the answer that's greater than 400. That would make any sense. So like if you had 4 options, 3 of them were less than 400, you even have to do the problem. Just select the one that was greater than 400 because that's the only choice that makes sense. So again, that's also a good test taking strategy. All right, but we need to get x by itself. How to get x by itself? Multiply. So multiply 400 for both sides. It'll cancel off over there. Multiply it on this side. So now we have 400 times tangent. I don't know, I'm writing this equals x. So what is x? It's going to have to be greater than 400. So try plugging it in, see what you come up with. Should be greater than 4. Well, for the length here, should be greater than 400. Let's. Oh, that's really big. No, that's really big. Is everything in? Oh, you get tangent first. On that calculator, remember you got to set the number. Equals. I think that's what it is. Yep. All right. So correct answer is 460. If we round to the whole number, 460 feet. Anybody having trouble getting that? And go over it if you're having trouble. That's what you should ask for help. All right. Number 2. Now, this one's talking about angled elevation to the sun. So we talked about shadows and the sun a little bit in our last section because we had a couple word problems where we used a shadow. Something you need to know is the angled elevation to the sun will always be the same. So if I was to look up at the sun, it's going to be the same. Also, it will always be the same with any shadow on the ground. It'll be the same angle elevation. All right, because the sun's so far away that that angle will always be the same. Now, for this problem, we have 18 meters. We have 12.5 meters, and we're trying to find the angle of elevation to the sun. So they have this telephone pole, they have the shadow. What is that angle of elevation? Well, same thing that we did in the last one. Label our sides. What 2 sides do we have? Yeah, it happens to be the same ones here. All right. But the problem is different because now we're finding an angle instead. Right? This is where we have to do the -1, the inverse operation. So we still have a tangent problem. So when we set it up, it's tangent of x equals opposite, which is 12.5, over adjacent, which was 18. So now you're right to say this is where we use that -1 feature in our calculator because if we're solving for an angle, you're going to have to use the inverse operations. This isn't like the last one where we had to divide off. Oh, sorry, that wasn't even where we divided. I'm thinking one of the ones earlier. But we're not getting rid of tangent of x. We're just getting rid of tangent. We have to undo that operation. So to undo tangent, we're doing inverse tangent. So inverse tangent of both sides. On this side, it cancels off. On this side, it's inverse tangent of 12.5 over 18. So plug that in. 12.5 divided by 18. Now again, be careful when you plug this in. If you want to type the whole thing, that's great. You type it as a fraction, 12.5 over 18. Take the inverse tangent of that. Should be good. Now, if you do it as division, be careful because on a lot of your calculators, if you're using, again, the TI-30XA, that little black one, or you're using like an iPhone, when you do this, you need to make sure you first do 12.5 divided by 18, enter, so you get an answer there, and then inverse tangent. Otherwise, your answer will get messed up. Okay, so on this one, you really don't have to worry about closing parentheses because it's not going to change our value. But if you wanted to, if it's an error to go over.
3486. That's what it's called, 34, 86.
Yeah, no problem. But on that type of problem, if you left it open, so there's nothing, no other operation happens afterwards, it would still be right. Divided by 18. I should hit enter. And now, inverse tangent. Second tangent. Nope, that's it. That's it. That should be your answer right there. What'd you get? 34 degrees. Oh, 0.7. So round it up. Did it say what to round to? I don't see it. Let's go out one decimal. Oh, that's not. Point, you said 7? We'll start around there. 4.7. All right. I would love to do at least one more. Let's look at number 3. What time did we get out of this class period? 22. We might have time for 2 more. Let's do 3 and see where we're at. All right. The ski run is 1,000 yards long with a vertical drop of 208. Find the angle of depression from the top of the ski run to the bottom. Now, just looking at this picture, that angle is pretty small, right? But first off, the angle of depression, is it in the triangle that they drew? No. So this is the angle that they want us to find, but that's not in the triangle. So I can do a couple of different things, but I could just choose to find the angle of elevation instead, because I know that they have to be congruent. So if this is the angle we're going to use, since it's inside the triangle, what 2 pieces do I have? Opposite and hypotenuse. Yeah, I heard a lot of both ways that either way you say that's fine, but opposite and hypotenuse. So now, if it's opposite and hypotenuse, what are we using this time? Sine. So sine of x equals the opposite, which was 208, over the hypotenuse. Now, before we even type this in, that number is going to be pretty small, right? Just looking at a triangle. I mean, is this triangle, is that even to scale? No. I mean, really, if these were 2 values, it'd be stretched out even further, right? Because that's not 5 times the length of that piece right now. So that means that angle is going to be very tiny. So we're going to get a small number. So now, how do I solve? I have sine of x currently. I need x by itself.
Times 1,000.
Not divide. No. What are we finding? A side or an angle? Inverse. If we're finding an angle, we got to do the inverse, right? Get rid of sine. So inverse sine. And that should give us our answer. Plug it in, see what you get. Yeah, it's going to be a pretty small number. Got to be greater than 0. Definitely going to be less than 45. 12 you got? That sounds right. Yeah. It's going to be a pretty small number. Just looking at what we had at size. Ooh. So I got comfortable with 12. You said you got 6.
Well, yeah, it's 12, but like I'm just saying like this.
Yeah. Would you?
I got this. I got 12.00.
Oh, I put 1. I put 15 or 18.
Oh. Yeah, that would definitely make it smaller. So. All right. Any other questions there? We got 5 minutes. You Want to do another example?
Yeah.
All right, on this one, traffic control, let's see. I haven't done this one yet today because I ran out of time. From the top of the 120-foot tower, an aircraft controller observes an airplane on the runway at an angle of depression of 19. How far from the base of the tower is the airplane? Well, kind of similar to this one, that's my angle of depression. I could come down here and say, all right, that's my angle of depression, my angle of elevation is the same. And I would choose to use this one. You do have a couple different options on how you could go about solving it, but I like using the idea of these are congruent. We now have an angle in triangle, and I can solve from there. So that's 19. And I have these two sides. This is opposite. This is adjacent. I can plug it in. So opposite adjacent is tangent. Tangent of 19 degrees equals 120 over x. So this is a lot like one of those homework problems from last night. We got x on the bottom. We're going to multiply x to the other side. We still got to get x by itself. So currently it's held together by multiplication. We need to divide off that tangent of 19. And that should give us an answer. So 120 divided by a tangent of 19 is going to be a pretty far distance there. I guess it's probably somewhere around 2,000. What is it? 3? Even bigger. All right, 3. 348.5. Wait.
Or no, just you want to say
3,000 or 300? Should be bigger. Right? That was 19. So this is the small side. This should be the big side. Maybe I'm wrong. 348, you said?
Yeah.
Okay, no, yeah, I think you're good. I think you're good. I was thinking it was gonna be bigger, but that sounds right. Yes, so homework, ready? For that one, 120, calculator using. That one, do 120 divided by 19. Hit tangent because you need a tangent of 19, and then hit equals. Should get it. All right, yeah, no problem. So for homework, now listen, there is another page here where I'm not doing this page. All right, this is really way extra than what you need for geometry. If you want to look at it, you want to try it, you're more than welcome to try it. As far as the assignment goes, on the back side, there is 2 sections. The first section, I want you to do all of them except for the one that says ballooning. You can skip that one. That's using that other idea that's on the front page. I said it's kind of just too much. And then on the second part, I want you to try them all except for the one that's number 6, the one that says geography. Again, that's another example using that other idea from that front page that I don't want you to do. So on the back, it's essentially 12 problems. 12 problems. That's less than what it was yesterday. It's all the same as what we've done though. It's just now using angle elevation, angle depression. Some of you have to draw a picture for. So
We're arguing about my mom about birthday. How did you not know about birthday?
Should just did black, son. Why didn't they just get stickers? They could have just got some sparkly stickers, just like the other schools back. That's gonna be fucking cool. Yeah, well, oh shit, girl got a smile and shit. Girl got a smile and shit. Look at you, your teeth.
He was like, he was like, he was telling so give me that, but all right, oh, they already know about me. Oh, he was like this. Man, that shit is so bad. Bro, I'm about to go to the store and get some stickers, bro, because I'm not wearing that shit, bro. Y'all need to go buy they need to go buy stickers. That's what I'm about to go buy some stickers for them and make my own. Make mine. I'm about to go get my friends from Leonard, bro. What that one for the day? Leonard always be snapping with the senior numbers, bro. Because, bro, I'm not gonna lie. One thing I learned I was good was SBA, bro. SBA Leonard was fine.
You're so picky.